on the left side climbing up this graph. That means from here to here it's increasing. So I want you to put a plus sign. Alright, when he gets to this dot, he kind of bottoms out, correct? And then from here to here he's climbing down. So this is going to be what? Decreasing. Then he kind of bottoms out right here. Then he goes back uphill. So from here to here it's increasing. What about from this point on? What's he doing? Is he decreasing or increasing?
No.
So we call this constant. Alright, anytime it's asking you like intervals of increase or decrease, can you increase or decrease horizontally?
No.
No, only vertically, right? Only up and down. So it's asking, make sure you write this down, where is it increasing, decreasing? It's asking where is it for your x values increasing or decreasing, because the y is actually the value it's increasing or decreasing. The x is from where it's increasing to decreasing. So for example, Pierre, from here to here, this when it's increasing, what is the x value? Where does it start? Negative infinity. Good, because this is going to go down forever and isn't it going to go left forever? Yes. So it's increasing from negative infinity, and where does he stop increasing right here?
3.
Negative 3. Now, we can't include that negative 3 right here because he's just standing still. He's not increasing or decreasing, right? So we put a parenthesis. Why did I put? Oh, this means increasing. Alright, so where is he decreasing? Tell me the interval.
Negative 3.
And stops at where? 1. Very good. That's decreasing. This one's he's increasing again, right? So tell me the next interval he's increasing from. 1 to 4. Very good. Where is he constant? Very good. So all of these will have parentheses.
I don't see where he's decreasing.
Decreasing? Where he's going downhill from here to here. Alright, so I want you to try this one kind of on your own, but let's label this first. It's going to be negative 1, negative 2. And go ahead and tell me all the intervals where he's increasing, decreasing, or constant. Out to the side. Increasing, decreasing, or constant. I was talking about this graph down here. This is the one I want y'all to do. This one's the same graph. That should have the same table. Because the second graph listed is the same as the first one, so it'll have the same intervals. first interval. Where would it stop at?
Oh, then where's the
Negative infinity. It stops at negative 5. Keep going. That should be what right here?
Just go on. Isn't this positive?
But yeah, we're not talking about y values, so we're talking about x values, right? This should be a negative infinity. That's this portion, right? Because I know it looks like it's going positive for me, and it would if it was a y value. But the x value is going to what? Yes. And this, if you started walking here, would you be walking up or down? You'd be walking down. So it should be decreasing. So right here. Alright, let's talk about these. One person give me a positive interval.
0 and 1?
0 to 1. So from right here to right here. Is it increasing?
No.
Yes, but it's not the whole interval. Somebody give me an increasing interval.
Negative 5 and negative 3.
Negative 5 to negative 3. That's correct, right? And when you read graphs, like if you were reading this sentence right here, would you read from left to right or right to left?
Left to right.
Same thing with the graphs. Okay? So from Antonio said this one is increasing. Is that true? Yes. If you were walking on this line, you'd be walking uphill. So it's negative 5 to negative 3. Very good. Somebody give me another positive.
Negative 1, positive 1.
Yes, negative 1 to positive 1, walking uphill, right? Is there any more?
No.
4 to 5. Very good. Walking uphill right here. Any other positive? Good. So I'm going to put all the green positives so we can see that better. Any question about that? Alright, give me a decreasing.
I got negative infinity. 5.
Yes, that's one. Negative infinity to negative 5. Now a lot of y'all, that's this interval. Put positive infinity to negative
How
5.
you get infinity?
How did I get negative infinity?
Yeah.
You just told me that.
I know. I'm just saying. Like, I'm just assuming because like it's on the end. There's like nothing
Yes.
over there. Okay.
So you're looking at the x value. If this kept going, this would go all the way to what? No, negative infinity. Take that hood off. Thank you. Alright, tell me another negative interval. 1 to 4. Very good. Going downhill here. Because you're going downhill from 1 to 4. Going down. What's the constant intervals?
0, negative 3, 0, 1, 0, 5.
Negative 3 to negative 1. Very good. Straight line right here. And what's the last one? 5 to what? Good. So again, this one was decreasing, increasing, constant. Increasing, decreasing, increasing, constant. Alright, how do y'all feel about those? Good?
I'm good to leave.
Good.
You gonna be on the test.
Mhm.
What's that?
The test that's coming up Tuesday, and I'm going to give y'all a study guide tomorrow for it. Okay. Alright, flip it over.
Next Tuesday?
Yes, Tuesday. Actually, I think it's... Check that calendar behind you. Is it Tuesday or Wednesday of next week? Test. Oh, it's not going to be for a while. Never mind. You won't have a test next week, sorry. Alright. So we've talked about increasing, decreasing. Next we're going to talk about relative mins and maximums. Relative maxes are the tops of the mountains. So think about if you were walking on this, the tops of the mountains would be right here, correct? Those are relative maxes because they're the highest points in their little neighborhoods. So relative to points around them. The relative minimum, and I'll put relative mins, are the bottoms of the valleys. So that would be these two. They're the lowest point in their area. So the way I want you to write these, for example, tell me the points where we have our relative maxes. And 2, 1. This is how I want you to write them. relative max, and you can just write rel max of, and when it's talking about max, we're talking about height, right? So we're talking about which value? X or Y? Y. Height. So what is the Y at this point? 2. So put relative max of 2 at X equals, and what's the X value? Very good. That's how you would write your answer. The other relative max would be how high? 1 at what? 2. So same thing for minimum. We're talking about the Y value. So Amber, tell me how to write the first relative minimum. Very good. Darian, tell me the next one.
Rel min is 4.
Is that the Y value or X value?
Negative 1.
At where?
X is 4.
Good. Now I want you to find all the relative mins and max of this. And I know there's not numbers, they all go by ones, okay? So I want you to find the relative min and max, and they're also called the relative extrema for this graph on your own. And make sure you write it out correctly. Sure. You already did your maxes, right? Now find your lowest points in their area. There we go. Alright, Brandon, tell me this point.
That is 5, 1.
5, 1. There we go. Negative 5, 1. Kelsey, tell me this one.
Negative 3, 2.
Alyssa, tell me this one. Kaya, tell me this one. Antonia, tell me this one.
4, 1.
Ransom, never mind, there's no more. Okay, so tell me which of these are relative max. Go ahead.
I have a question.
Yes.
Yeah.
Thank you. It should. Alright, which ones are our relative maxes?
8, negative 28.
That would be a minimum because it's at the bottom. That'd be a min. This one would be a what?
Man.
Right here? Max, 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 right? Alright, Camden, tell me how to write one of them. It doesn't matter which one. Justin, give me another one, how to write it.
You did 8.
You can do any of them. Try this one. This is a relative what? Of. At. Good. Alright, Jalen, do another one.
Hold on, wait. We're doing mean. Which one is, how many
Any of
means is
them.
there?
You tell me?
I got 2.
Yes. Tell me the other one.
Which one you did? Oh, I got a real min of 0 at x equals 2.
Good. And I don't think we have to go over the other ones. Y'all know how to do these, right? Any questions? Alright, from these two examples, we can say that a relative maximum, so these are these, occur when the graph changes from what to what? Good. Increasing to decreasing, right? That's when a relative max occurs. When it goes from increasing to a decreasing interval. And so we can say a minimum occurs when it goes from what? Decreasing to increasing. Good. Oops. Very good. Alright, those are pretty easy, right? Everybody's good with those. Now let's talk about two different kinds of functions. There's even and odd functions. Okay? A function is even if f of negative x equals f of x, and we'll get into what that means. And it means when you replace x with negative x in the original, you'll come out with the same function after you plug negative x in. And it's odd if you plug in negative x and it comes out with all different signs for your new function. I know that doesn't really make sense in words, so let's put it into practice. So for each one of these, we're finding f of negative x. Okay? What is the difference between f of negative x and f of x? Not rhetorical. What's the difference between these two? Good. So they want us to change this to all to what? Negative x's. So let's rewrite this whole equation, except put parentheses instead of x's. So write blank cubed minus 6 blank, and we're going to plug in what for those blanks? Negative x. So that would change what here? What's negative x cubed? Negative x cubed, right? What would this be? Good. This is f of negative x. So let's compare what we just found with the original. What happened to all the signs? They changed, right? So this is what kind of function? Odd. Very good. So if all the signs change, it's going to be odd. It was positive, now it's negative. This was negative, now it's positive. So it's odd. Alright, for this one, plugging in negative x instead of positive. What would this be once we raise it to the 4th power? Would it be positive or negative? Positive. And this one would be a positive x squared with a negative 2. That's going to make what? Negative 2x squared. Did any of the signs change? No, this is exactly the same as this, right? So that means this function is what? Even. Very good. Do 3 on your own. So plugging in negative x for x. Alright, what'd y'all get when you plugged in negative x squared? What is g of negative x?
X squared minus 2x plus 1.
So did all the signs change? 2 of them did. No, just one of them did. So not all of them changed, right? And it's not the same function. So this is neither even or odd. It's neither one. Because either all the signs have to change or none of them. If only some of them change, then it's not even or odd function. Questions about that? Alright, do 4 and 5 too on the back. Alright, Katie, tell me what would happen once I plug negative x in. What would f of negative x be?
X squared.
How do we know that this is going to be positive?
Because x times x, or negative x and negative x is just x.
Good. So anything we plug in negative with an even exponent is going to be what? Positive. Anything you plug in with a odd exponent is going to be what? Negative if it's negative. So this is what kind of function? Because none of the signs change. Very good. And then Cade, what would happen here if I plugged in negative x?
I believe it would stay negative.
Yes, because it's a odd exponent. And so this would be what?
I would leave it on.
Correct, because only one of the signs changed. Everybody good with those? You can also tell if it's even or odd just by looking at a graph. Okay? Even functions are symmetric across the y-axis, and that's this one, right? Notice how this function, like if I just took it and flipped it on this other side over the y-axis, it'd be the same thing. That's how you can tell it's even, because it's symmetric across this line. Okay? Odd functions are symmetric across the origin. What is the origin? The middle, right? So if I flipped it across here, like this, I wish I had something I could show you. If I flipped it across here, see how it'd be the same thing? If I flipped it across the origin? So this is odd. So again, even flips across the y-axis. Odd flips across the origin. What about this one? Neither, because could I flip it across the y-axis? No. And could I flip it across the origin? And it'd be the same thing? No. So you can check it by just looking at the graphs. Any questions about that?
So like they line up.
Yes. Like a mirror. Alright, we're about to play a game, and whoever wins the game can get either 10 points on their test that we took last week. 10 points on the test we took last week. Let's make it 5 actually. 5 on the test we took last week, or you can draw out of the box. And there's all kinds of stuff in there, okay? Now, if you cannot play this game, it's on Kahoot, so if your phone, if you can't connect, then go ahead and be working on your homework from last night. But if you can connect, you can use your notes, and you'll probably need just